Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous video tutorial, we said goodbye to Landsat and Sentinel for now, obviously. Yeah, for now. And we said hello to population. So we started looking at WorldPop, SEDAC, and LandScan, the three most widely used gridded population data sets. And we basically just went through these landing pages in the Earth engine via the data set and searched for it. And then we basically went to their websites and it's all in the previous tutorial. And then we basically ended our video tutorial by generating the images, the Landsat, the WorldPop, the SEDAC, and the LandScan images. And we basically looked at the differences, similarities, zooming in, zooming out. The main obvious difference is that WorldPop is on a much lower resolution, around 100 meters, whereas WorldPop, SEDAC, and LandScan is around 1,000, so multiple of 100. Okay, 2 zeros. Now that's important because we're gonna bring that into our next set when we looked at comparing the three. Okay, so that's quite important, and obviously the use of the inspector tool, etc., etc. Okay, so that's quite important. So now, as I said, what we've done is we've generated 2 images or 2 layers for each of the data sets. And we basically looked at a beginning value and an end value. Okay, so for WorldPop, we have got a 2000 image and a 2021 image. For SED, in fact, it should be a 2020 image, not the 2021. It's a bit misleading. I see that they haven't updated for 2021, so it should be 2020. A SEDAC for 2000, a SEDAC for 2020, a LandScan for 2000, and a LandScan for 2022. Roughly about 20 images for the first two, and 22 images in the collection for LandScan. Okay, so we've got this. We've given it a bit of color using our visualization parameters, our per letter, etc., etc. We add them. Remember, we also created an export function where we can export each of these images or layers to our Google folder, which we call project. In this case, you can obviously call it whatever you like to. Okay, so it will be downloaded or uploaded into your folder, a Google folder, and from your Google folder, you simply just download it to your desktop or your laptop or wherever you want to download it to, and then from there you can obviously import it into any of your GIS programs such as ArcGIS or QGIS for further analysis and work with. So that's in general the standard procedure. You generate the images and you transfer it via that export function to another GIS program from where it may be easier to work with, more functions to work with, etc., etc. Okay, so we've generated the 6 functions after 6 images. There they sit. Okay, and we can visually compare them with each other, obviously, and amongst each others to see where the similarities, the differences, and then identify areas that have recorded increases in population numbers or areas where there's been a decline in population numbers, etc., etc. But visually, yeah, just to compare 2 images is not that straightforward. So what we can do is we can generate a temporal difference image, which we basically just subtract these 2 images from one another. Okay, so you can within Code Editor subtract the WorldPop 2021 with 2000. You can subtract the SEDAC from the SEDAC. You can subtract the LandScan from the LandScan. So you can create what we call a temporal difference image Obviously, that would be for the whole 20 years, and obviously you can divide it by the 20, multiply by 100 to get a percentage image, whatever the case. So all those things are entirely possible. So to generate a temporal difference image, we simply just, let me quickly go there in the code, let's make it bigger. We basically just subtract the two. Okay, that's the piece of code that you need. Well, first of all, we create a visualization parameter, and we're going to apply that to all three of them, because the differences should be fairly similar in terms of the differences itself between the pre and the post. I don't think there's going to be a big differences. And we give it just basically three colors: a negative, a constant, and an increase, basically. And the code is basically just, you take the latest one and you subtract it by the earliest one. You subtract the 2020 image from the 2000 image. Okay, so that's a piece of code. That's basically that. And then you just add it to your layers using our normal code. And we also create an export function for that temporal difference. Okay, so this is W, this is for WorldPop. Okay, so the WorldPop 2020 minus the WorldPop 2000, that gives you a temporal difference image between those two periods. We add it to our layer using our average or standard this visualization parameter that we're going to use for all three of them. Again, you can create separate ones, that's up to you. Okay, so we're going to create an export function for that, where we're going to export the variable WPOP subtract, which is the calculation. We give it a name, and we export it to our project folder in Google Earth, in Google. Okay, and then we can also create a histogram for our temporal difference image. Okay, so there's our little histogram where we just using the histogram function. What are we going to put in the histogram? The WorldPop subtract table, and we're going to give it a width of about 50 units or 50 people, for lack of a better word, and we're going to just print it. And we're going to do this code for all three of our data sets. And the only thing you do is change the variable details up here. You change that, and obviously the description, and that's basically that. Then, as I said, there's a SEDAC, so I'll just use the SPOP subtract, SEDAC population subtract, and remember, just make sure that you pull that name through now into this. For example, make sure it's there updated and there updated. The rest is exactly the same. With SEDAC, I'm giving it a 100, not a width of 50, but a width of 100. And the reason simply for that is because of it's got a much higher temporal resolution than WorldPop. But play around with these numbers and see what fits your desire or your analysis best. Okay. Again, these are in the eyes of the beholder, so to speak. Okay, so play around with these numbers, with this bin width, and yeah, that's up to you. And there's the LandScan. Okay, so it's a LandScan 2022 minus a LandScan 2000. I give it that variable name. We display that variable. You're still using that general visualization parameters. I will export it to my project folder in Google, in my Google Drive, and I also create a histogram of this. And again, I'm giving it a bin width or a bucket width of 100 because its temporal resolution is similar to SEDAC. So there's my three temporal differences, and you can use if you change the filter dates, obviously you're going to create different temporal differences depending on your filter date. In our case, our filter date is first image to the last image. But let's say you just want to do the last 5 years, then you just change your filter dates, and it will calculate for that 5 years or whatever. So you can play around with the dates to create different filtered dates, and that will give you different temporal images. If you're just interested in what's happening, let's say post-COVID, then you'll use pre-COVID as your initial date, and then post-COVID to see whether there's been inward migration or outward migration, for example. Okay, so you just play around with these dates. Okay, so you press save and you press run. You remember, save and run. So there is my my 3 histograms. There's the histogram for WorldPop. Remember, WorldPop. Let's go there again. Where's WorldPop? There we go. Sorry, let me just quickly go. Where's the WorldPop temporal change? Okay, there we go. Okay, so this is the 2020 minus the 2000 histogram image. Okay, so this is the histogram of, remember, it takes purely the 2020 and subtract it, so it's 2 images that subtract. There's no averages, etc., etc. So it's purely just that. And you'll see, in general, of the pixels, remember this is pixels here, of the pixels, 1,336 recorded a decrease, but the vast majority, 4.whatever million, 4,400,000, blah, 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 pixels recorded either a 0 or a positive increase of up to 50. Now, this makes sense because most of the locations don't have population, so there wouldn't be any change. And that's why you have this. Now, you can ideally try to change your bin so that you distinguish between those pixels that have stayed the same. There's very little change, minimal change, and those that have recorded an increase, because here the stay the same, no change, and the increase are put together in this bin, so it's difficult to see. But you can see there's about 6 million pixels in this image. Okay, we go to SEDAC, and you can see again between 0 and what that number is, 100. Yeah, increase the vast majority of lies. So according to SEDAC, there's no decreases, just an increases, but again, very small increases between 0 and 50 over 20 years. Not between 0 and 100 over 50 years. 20 years. There is LandScan. So LandScan actually has quite a large decrease, quite a number of decrease, but I think that's purely because Landsat warns that you can't simply subtract it because their methodologies have changed over time. So again, as per my previous videos, do a bit of research on these numbers. Don't take these numbers as is. Do your research. Try to get understanding why would the vast 90% of the images record a decrease in population. Logically doesn't make any sense. Okay, so go to the website of Landscape, go and find out what they say in the methodologies, and they basically say that you can't simply compare. And visually, you can actually, so let's go visually. You'll see the difference. Okay, so let's have a look. So there is the LandScan 2000. You can see all these places, according to them, had a population. These are actually main roads. So they've added, so they basically said, there's our populations. Now, if you look at the 22 calculation, you see most of those populations are missing. So therefore, the big decrease in population numbers. So I think it's purely a statistical error and not actuality. It's not reality. You can see it from the image. The statistics make 100% sense if you just compare it for the image. Okay, so in a nutshell, if you look at the 3 histograms of the temporal difference, you can see that most pixels, I would think about 95% of the pixels either recorded no change or very, very small increase. And the pixels where there's been an increase has been very, very limited, and it's been very, very small. So typically this suggests that there hasn't been much of a population expansion or growth in this particular municipality. Very, very small increase in population numbers. and they are limited to a number of isolated locations, i.e. pixels. So that's sort of what one can generalize around the temporal change in population. But again, it depends very much from your time frame. It depends very much from where your filter dates from the beginning date. Because remember, what could have happened is there could have been a significant increase up to a certain point, and then quite a steep, all of a sudden, decrease. So you would miss that time series effect, if I want to call it that. So just be careful just to use a beginning and an end, and because it might be, your outcome or your conclusion is dependent on those 2 years, and that one of those years or both could have been an anomaly, and therefore your conclusion would be noise rather than reality. So just be careful. But anyway, so that is how we create temporal difference images, and how we generate histograms for the temporal difference images, and how we display them in Google in the engine. And obviously, remember, you can also export these ones. Okay, so remember, we can press on this little sign here, and it's an expansion sign, and it increases the expansion. Now you can view it, and obviously you can download it to Excel on your desktop, from where you can work further with it. Okay, so remember, that's quite a neat function. All these images, all these graphs or tables or statistics that's generated here, you can actually export. Okay, so that's quite a neat function. So rather than just speculate, okay, so yeah, sorry, we visually need to look at them. Let's just unselect my call it absolute images. There's my temporal WorldPop population temporal difference. Now, again, remember, I have to zoom in because it's such a small resolution. I have to zoom in. Okay, so have a look there. So there is a temporal difference. So clearly these areas have recorded high increases in population versus let's say some of these populated areas where they've basically recorded a stable population. Let's have a look at SEDAC. SEDAC also indicates, you can see the difference in the spatial resolution. You can clearly see it. With this big spatial resolution, you lose a lot of the finer detail, so to speak. And then LandScan. Okay, and LandScan. There's LandScan. That's LandScan. That's SEDAC, and that's WorldPop. So let's have a look quickly at the inspector. Let's choose. I actually need to select that point. Okay, so let's see what the inspector says. Okay, so there's a temporal difference. So according to WorldPop, there's been an increase in 145 people in that specific location. According to SEDAC, there's been an increase of 2273, and according to LandScan, there's been an increase of 783. So fairly all over the place, but again, it could be because of, remember, LandScan is 2 years later, so it could be that there was a decrease from 2020 to 2002, so therefore the 22 number is much lower than the 2020 number. That could be a possible reason. So in fact, you should make the filter dates the same. Obviously, the difference is also between WorldPop and SEDAC is the spatial difference, spectral difference, pixel size difference, etc., etc. So interesting, you can see that the LandScan value in 22 was 793, and the LandScan value in 2000 was 10. You can see the 783, and then in the population was 5 and 29, and therefore this. So you can see that they've calculated just simply subtracting those two. Okay, yeah. So visually you can go and have a look, and now obviously you can isolate those areas that recorded decreases in population. You can go and count how many of those areas, etc. So there's a whole lot of other things you can actually now add on to this code. So I think I'm gonna, for this particular video, let's pause it on this note. And in the next video, we're going to look at time series. Two options when it comes to time series to further expand on our analysis of these three data sets, because there's much more than just generating two isolated images, subtracting them. There's much more that we can do. Obviously, it's up to you whether you want to do that in the Earth Engine or whether you want to do it in your GIS program. That's a decision you have to make. Anyway, so there they are. Remember to save and run, save and run, save and run. There we are with the code. It's generating all these nice little things, and everything is exportable for you to continue working in another program of your choice. Okay, so there they all are, all of them, and we're going to continue expanding on the basic images. Okay, well, thanks for joining me on this population journey, so-called population journey. Something different, single band, not multiple band, single band, and it gives another perspective. Okay, yeah, so thank you for joining. Please remember to like and subscribe. Please forward and share as wide as possible, so that I can keep on with this journey. The journey is still long. We still have a long way to go, and I look forward to having you on board all the way, non-stop. Okay, well, thank you, and I'll see you on the other side.